Hello, it's Petri Muinonen, and I am presenting again about the logarithmic pole model. I have been asked about the motivations of this study I'm doing, and there are many challenges with the standard model, and one of those is the big number of parameters that are practically taken from only from experiment so there are not actual predictions to obtain those from a model directly. And then also there are many quantum numbers and rules for those numbers. So what I have thought would be necessary to try and substitute that kind of rule-based approach with a more calculable approach. And my approach has been that of combinatorics. So let's construct four known interactions from scratch. So the limited range interactions, weak and strong, they have been studied a lot in high energy um, experiments, and however, the explicit functions of distance have not been very much presented or in foreground of the publicized results, but it's rather that uncertainty principles and kind of interpretations of the quantum theory somehow have covered that kind of approach. And these limited range interactions are repulsive, weak, and attractive, strong. Then we have also beyond the standard model, we have gravity Newtonian interaction, and within the standard model Coulomb interaction. Those have both in common 1 over r squared proportionality, but there is also this disparity of coefficients that is kind of explanation is being looked for there. So the new approach in this logarithmic pole model is that matter is seen as built from aggregates of logarithmic poles. Particles are these aggregates, negative nits, positive pits, and the universe is seen as a continuous 3D potential at zero value, and it would be a 3D shell within the 4D space. And limited range interactions arise from primary 4D pole-to-pole accelerations, while long-range interactions are caused by secondary dipole accelerations on nits or pits and their projection into 3D. The accelerations arising in logarithmic pole model are always described as pairwise accelerations between different combinations of poles, and the strength of acceleration is always 1 over d, where the d is for distance between the poles, and then for repulsion or attraction there are postulated rules that are depicted on this page. You can see that the candidate for weak force is nit repulsion, and a candidate for strong force is pit-to-pit attraction. Then for long-range interactions, Coulombic and Newtonian ones, along the 3D brane, there are these accelerations caused by logarithmic dipole onto nit and pit respectively. And you can see that there is this zero brane or zero potential already produced by the dipole itself, but in a big picture, cosmological view, the zero brane becomes what is our universe. It's a zero potential of the whole system, and most probably spherical, a shell, 3D shell in shape. Logarithmic pole model is also very quantifiable. So here you can see how nit and pit, the dipole, would be positioned in one phase of its oscillation, how it would be positioned against the 3D brane that runs here. And we have here distances, unit distances from the axis of the dipole. And these distances, one corresponds approximately to the Planck length. And you can see that while 1 over r squared Coulomb acceleration goes to infinity at zero distance, this model predicts instead a finite value. Like in the previous slide, the position of the classical particle is shown by this brown disk here, and the distance in 3D from that particle is shown here. And going towards the particle, you are getting values that are going towards infinity. In this case, we are talking about the Newtonian potential. The present model I have been working on will give a finite value at zero distance, and this is practically because there is no classical particle here. Instead, we have pit and nit that are displaced a bit from these 3D brane running here, and so infinities are avoided. The model in that sense is very robust. The model depicts particles as aggregates of poles, and in many cases there is also balance between positive and negative poles. So in that case you can say that aggregates are also aggregates of dipoles, and the dipole is depicted here on the right hand side, and below we can see various aggregates where, for instance, the second aggregate from the left is what is thought to be like electron, and you can see that there are 3 dipoles, so it means that we have 3 pits in the core of the aggregates, and we have a triangular constellation of nits around it, and you can see that based on their attraction and repulsion rules, the vertices consisting of nits, they are symmetrically around the PT core, and the zero potential cuts through these aggregates somewhere between pit and nit. It is very plausible. Actually, I have calculated for many of these aggregates the distance, the specific distance where the potential is 0, and it cuts through one of the dipoles, and these structures are oscillating symmetrically around the core, and actually this is kind of gauge invariance, since what we see as a potential along the 3D brane, it is independent of the phase of the oscillation, it seems. This is yet another demonstration that the model actually produces very quantitative results. The values seen on the left hand side are relative masses of a set of particles, and factorials are used to produce these numbers. At this point you can ignore the sign, but the absolute value gives a kind of estimate for relative masses, and the scale is fixed to the neutron mass, but equally it could be fixed to the Higgs mass, and you can see that very many particles are given rather good estimates for their masses, especially the bigger ones that have many poles and that are many they are more symmetrical in 4D space. For instance, for electron, the mass estimate is not so good. We are talking about the flat 2D structure practically in 4D space, and so the model is in that sense not so exact. I'm still developing the ways to calculate that better. The factorials also are equal to definite integrals from 0 to 1 of logarithmic higher order of logarithmic functions, and those arise from graph diagrams joining all the poles together. So what's the objective of these presentations? It is to get feedback from you. So please contact me and send comments and post questions. You can find me through YouTube channel Petri Muinonen, or giving comments to any of the videos. There is also a dedicated Facebook page, and you can also find me in LinkedIn and contact either privately or publicly. What I need here is ideas, what could be wrong in the model, so I'm eager to find ways to fix things that don't work and get to the version 1.1. At the present there is only one free parameter in the model, and this is the number of the poles in the system, and from that we also get calculated the speed of light and so on. You can go and see the longer video that has been presented like 3 weeks ago. Thank you very much. Bye.